Hey Algebra 2 students, welcome to our new unit. We have officially finished our unit on Chapter 3, Polynomial Functions. And with the last 2 weeks before winter break, we are going to do kind of a little mini unit, or mini units, plural. We're going to be looking at exponents. And the other topic we're going to be looking at in these next 2 weeks is radicals, which is like a fancy way of talking about square roots and cube roots. So we're first going to be working with exponents today, Monday, Tuesday, and then towards the end of the week on Thursday, we'll start kind of moving to radicals and then practicing those topics the following week. So in your notebook, if you guys could go ahead and make sure to label the topic. We're looking at exponents. In the green textbook, this is chapter R.2. So it's part of the review chapter, but it does fit in nicely in where we are. Now that we've done some foundational skills, we've talked about functions, now is a good time to be reviewing some exponent properties with these last couple weeks. It was like perfect timing. So we're going to look at exponent properties. And the first thing that we're going to look at is a pattern. And after this pattern, most of our notes are going to be in a chart. It's like your exponent rules chart. So other than this, everything's really going to be here. So feel free to print that out if you want to print it out. So we're going to be looking for a pattern. Let's see. 10 to the fourth power. I know that's 10 times 10 times 10 times 10, right? The trick is it's a 1 with 1, 2, 3, 4 zeros, 10,000. 10 cubed is 1 with 3 zeros. 10 squared. 10 to the first. And now at this point, this is generally when I'll ask students to kind of think about if we have a pattern that could help us fill in for the 0 and the negatives, because it's a little bit less obvious for those. So the question is, how do you get from here to here to here? Is there anything that we're doing every single time to go from 10,000, 1,000, 100, 10? What are we doing to jump from number to number? What's that pattern? You might be noticing every time we're dividing by 10. So my logical conclusion would be that this next step would be 10 divided by 10 or 1. And then if I continued dividing by 10, I prefer to write this one as 1 over 10, right, like a tenth. This one would be 1 over, if I divide by 10, oops, sorry, it should be a 1. This one is 1 over, and it's kind of hard to see this one, but like if you think about like putting the 10 squared down below, it's kind of like 1 over 10 squared or 100, right? A tenth is a dime, right? A dime is a tenth of a dollar, and then a tenth of that is a penny, 1/100th of a dollar. So what we're noting here is something for these couple that we're going to be thinking about on our chart. So when you do 2 to the 0, there's not really a way to write expanded for this one. That one doesn't really have anything. In simplified form, 2 to the 0 equals 1. And the general rule is anything, and so I'm going to note that by an A, and say A to the 0 is 1. So it's like any number raised to the 0 power is 1. And you can nicely see that from the pattern that we were looking at up above. Otherwise, it's like a little bit weird, a little mystical for how that happens. And then the other thing we want to focus in on was what was happening over here, right? 10 to the negative 1 was 1 over 10. If I divided a tenth into 10 pieces, that was 100th, right? Thinking about like 10 cents divided by 10 is 1 cent, 1 penny, which is 100th. And keeping that in mind, right? It's 1 over 100, 1 over 1,000, right? Each of these, right? I could have said 10 to the negative second is 100th, which is the same thing as 1 over 10 squared. 10 to the negative third is 1 over 1,000, which is 1 over 10 cubed. So it's interesting, if you have a negative exponent, it seems to kind of go to the bottom of the fraction. So keeping that idea in mind, 2 to the negative third would be 1 over 2 cubed. And these don't really have anything useful for expanded form. So the general rule is if you have a to the negative nth power, right, this is just standing in place of regular numbers. We want to think about any case. That would be equal to 1 over, there we go, 1 over a to the nth power. And you can see that example there in numbers. So the way I always think about it is if there's negative exponent on top, like this is like the top of a fraction, right? It's a whole number. So the way I think about it is if you have a negative exponent on the top, it switches to the bottom of a fraction. And it also does vice versa as well. That's an important thing to put on the side here. So like if you have 1 over 2 to the, I'm going to use something other than 2. Let's say 1 over x to the negative second power. Let's just use a variable. So keeping in mind our rule, right, that says that it should be 1 over, right, a to the negative nth power. I should flip it. So if you think about it like this, 1 over x squared, then that would simplify to 1 is being divided by 1 over x squared. So I keep the first one, I switch to multiplication, and I flip, right? That's how I divide with fractions. And it actually becomes just x squared based on how the reciprocal dividing by that works. So the way I always think about it is that if I have something like 1 over x to the negative 2, that becomes just x squared, right? It goes on top. So if it's negative on bottom, it goes on top. Same thing if it's negative on the top of a fraction, like our example here, goes on bottom. We will definitely be practicing that one. That one tricks up students oftentimes with negatives. You'll probably like these ones a little bit more. They're a little bit more intuitive for our brains. So expanded form, x cubed times x to the 5th. 1, 2, 3. 1, 2, 3, 4, 5, right? Simplifying that, I have 1, 2, 3, 4, 5, 6, 7, 8. So I could just say that that's x to the 8th power. Notice, take a look back at the original problem. We had x cubed times x to the 5th. Notice how the 3 and the 5 give us that 8. If I wanted to write that generally, I would write a to the m power times a to the n power equals a to the m plus n. This is how your textbook generally writes it. In the green book, they generally have a base of a. Notice that in this case, you have to have the same base. We use the word base to refer to the bottom number that's being raised to a power. So like in our example, we had x cubed and x to the 5th. That would not have worked for like x cubed times y to the 5th, right? Those can't combine because they're different variables at the bottom. So keep that in mind as we're working. That's what we mean by having the same base. Let's try another one. If I have 11 x's over 7. Phew. Thinking about simplifying fractions, right? If I have the same thing on the top and the bottom of a fraction, like if I had the fraction, maybe I'll write it over here on the side. If I had the fraction like 8 over 2, actually maybe, let's do 8 over 6. You could write that as 2 times 4 and 2 times 3, right? Thinking about how we would normally take away that 2 and call this 4/3, right, simplifying our fraction. Anytime you have the same number on the top and the bottom, the 2 over 2 makes what we think about as a 1. And so anytime we use the word canceling, what we're really doing is making a 1, right? Nothing is really going away, it's just simplifying. So I'm making a 1, continuing to do that, right? Look at all the ones that we have matching up. So basically what happens then is all of those become 1, or some people use the phrase cancel out. And at the end you have x to the 4th over 1, which is the same thing as x to the 4th. And so a lot of people will think about that general rule as if you have something to the, different powers, right, with the same base, like a to the m over a to the n. The general rule is that you subtract. Okay. If you had the flip side of this, like the 7th power over the 11th, just kind of play that out. Right, if you think about it, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. if you think about how that would simplify, that would become 1 over x to the 4th. So it's the same kind of thing except for in the bottom versus the top. I always think about it, whichever one has more x's, that's where it's going to end up being. Just kind of play that out. Let's try another exponent property. We've got x cubed to the 5th power. If I do that to the 5th power, 1, 2, 3, 4, 5 of them. If I were to expand that even further, you can picture I would have a bunch of them, right? I would have 15 x's, right? Because each of those have 3. So it's x to the 15th power is our simplified version. You can generally see that the 15 comes from the 3 and the 5. So that multiplication there is really connecting back to what we do here, right? Because it's repeated addition, I'm adding a 3, a 3, a 3, a 3, a 3, right? I'm adding 5, 3, so if I'm repeatedly adding, I can also think about that as multiplying. So it really does connect back to our product rule. That's what we generally call the green one. Sorry to kind of jump around, but we call that generally a product rule, whereas the purple work is the quotient rule, kind of just from the operation that you're doing. And then I always think about this one as the power rule, because it deals with like that extra exponent. So I always think about this as the power rule, and it's like if you have a certain power raised to another power, you multiply them. That's what we see by the 3 and the 5 making the 15. Next one. So we've got xy squared to the 5th power. Okay, I think that's 5 of them. There we go. So if I were to put those together, notice I have 5 x's. So I could say that that's x to the 5th power. And I also have 2, 4, 6, 8, notice the squared, right, and 10. So that'll give me y to the 10th power. So for this one, the general rule is that this 5 gets applied to both of these exponents, right? So if you have a times b all being raised to the m power, the a gets raised to the m power and the b gets raised to the m power. Some people think about this like almost as distribution. It's kind of reminiscent, but it's different. It's not quite distribution like we're used to, right? Because distribution typically has something like 2 times x plus 5, right? There's always that plus sign. So it's different, but a lot of students kind of connect those concepts in their mind. And the final one for today in our exponent rule chart, we're going to look at 2/3 to the 4th power. I'm going to write that out 4 times. Okay, so if I am multiplying those, remember you multiply top times top, bottom times bottom. So that's going to be 2 times 2 times 2 times 2. That's going to be like 2 to the 4th over 3 to the 4th. I'm not going to actually multiply it out fully. The big idea is just if you have a over b raised to some power, you raise both the top and the bottom of your fraction. So these are some of the most common exponent manipulations that you'll see used throughout Algebra 2 and beyond. And that's why it's really foundational to make sure that we're reviewing them and continuing to build on what you saw in middle school. I've got just a couple of practice problems that we can explore together. So generally what you're asked to do is to simplify, which means you're combining exponents. And generally you don't want to leave any negative exponents. So for this first one, right, I'm multiplying everything. So I'm just going to rewrite that with like multiplication symbols. So I could rearrange and think about putting these together, right? I could rewrite that as negative 12. And then it's negative 12 times b to the negative 4th times b to the negative 7th. Now, those are both negative, so we would want to put them downstairs, right? They're on the exponent, and thinking back to our second rule right here, this one said that if you have something raised to a negative power, you put it in the denominator of the fraction, right? If it's in the top, it goes in the bottom. So I'm going to make this into a fraction and put b to the 4th times b to the 7th. Notice I can put those together using that product rule, right? I can say that, ooh, that's 11 b's all next to each other. So I'm going to rewrite that as b to the 11th power. And then why don't you guys try number 2, unpause when you're ready to check. Here's the answer. We'll go over